Hi friends, let's continue our discussion as we looked into something called the reduction. Reduction is a process of converting the problem A into problem B in polynomial time, and if somehow solution of polynomial B is found, then that will help us in identifying the solution for the problem A. Here, problem A, problem B are definitely not polynomial. Otherwise, there was no need to convert from one to other. So definitely they are bigger problems like exponential or even R type. So if we can convert one problem into another problem, then this solution to this problem, if somehow you found, so maybe magically, if this solution was found, then we call this problem as an NP problem. And because the solution of this can be mapped back, so this also will become a NP problem. So in our world of problems, this is a set of problems which can be solved in polynomial time, and this is a set of problems which may not be solved in polynomial time, but definitely can be verified. If the solution is made available, then the correctness of the solution can be verified in polynomial time. So that's a NP. So in NP, there are many problems. So there are many problems. So we can think of one problem, and to that problem, if all other problems can be reduced, so all the problems in any domain can be reduced to a single problem, then it means that this problem is the hardest problem among all these problems. So to give example of this, so let's take an example. So the problem is find median. So how do you find a median of a given list? Yes, of course, the problem is very simple. Convert this problem into a sorting problem. Convert this problem into a sorting problem. So you take the list, sort the problem, and then find the middle element of this sorted list. So that's this problem conversion we are doing. So that means we can convert our problem of finding median into a sorting problem. And the result of this sorting problem can be used to find solution of this problem. So when you say this conversion, so that when you say this reduction, so we can claim that finding median problem is reduced to sorting problem. Now the question is, which problem is harder? So as far as the complexity of the problem is concerned, so this problem is just finding the central value provided the list is sorted. But sorting is not that one time activity, it has to be done. So it can be order of n square in general, or the best case, if you go for a merge sort, it can be order of log n log n, whatever it is. And if this sorting is done and this sorted list is made available back to this problem, just picking up the, this is called A, then A of n by 2 is what we need to do. So that's simply order of 1. So what I am trying to convince you is, when one problem is reduced to another problem, the reduced side of the problem is more complicated to solve than the one from where it is reduced. This syntax is used, that finding median problem is reduced to sorting problem. So the right side is more complicated compared to the left side. So you can say this side, the arrow tail side is lighter and arrow head side is harder. So all of them are facing towards this problem. Therefore, this problem is harder than 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 this problem, and so on. Which is that this problem is harder than all these problems. So among all these, this is the hardest problem. So what are we trying to say now is, try to find the hardest problem. So depending on where that hardest problem, so we have all the problems in the NP. All the problems which are there in NP, you just try to find, can they be reduced to any one single problem. So there are two options. One option is they can be reduced to another problem here. All the problems are reduced to one single problem here, and there is another option that all are reduced to a single problem here. All these are reduced to a single problem here. Yeah, so what we can say is, this problem is harder than all these problems, of course, because this is what it is trying to tell. And at the same time, this problem is harder than all these problems. The only difference between these two is, this is inside our NP range and this is outside. So this one is inside NP range. Therefore, we claim that this is the problem. If solution is given to this, we can verify in polynomial time. Whereas this is outside our NP range. So the verification is not possible in polynomial time, whereas for this, verification is possible in polynomial time. So how do you differentiate? So this is a problem which is harder than all the problems in the NP, and this is another problem which is also harder than all the problems in NP. And this problem is called NP hard problem because it is harder than all, and this problem is called NP complete because it is hardest among all the NP problems, and it itself is also a NP problem because its solution can be verified in polynomial time, whereas this one, the solution cannot be verified in polynomial form. So now we can say L is NP complete if and only if first thing is L is a NP problem, and second is L is NP hard. That means all NP problems can be reduced to L. So all the NP problems can be reduced to L. That is, L is a NP hard problem, and this L is within the NP range. That means it can be verified in polynomial time, and it is harder than all the problems in the NP range. So that's NP complete. Now the question is, you need to identify the thing that it can be reduced to by all NP problems. So all means almost infinite numbers. So there can be infinite problems in this range. So if you just keep looking at all infinite possible to reduce to this or not is not practical. So we need to find some way out. What is it? So we need to look at. So let's see that in our next session. Thank you.